Hi everyone. I want to do one more pointer lecture just because I want to make sure we cover it more thoroughly. I know pointers can be confusing for a lot of people, so having multiple exposures to the concepts and having multiple things to practice over makes a lot of sense, and hopefully this will be helpful. So you can always pause the videos if you see an XKCD cartoon. I don't need to call them out, but at least you can get these jokes now. So first of all, before we even get going, I want you to try out this exercise. It's going to be very similar to what we did with finding the minimum index or the maximum index in the homework, but I'm going to make a slight twist on it. We're going to return both the minimum and the maximum at the same time in one function. Now, I could do this in one of two ways. The first way that we talked about was using a structure. I can make a brand new structure that has two integers inside of it and return that. So that is the first way. That's the first approach. Min, max, index. It will take in an array of integers. It will take in the size of the array, and it's going to return the min and the maximum index for that array. Approach number two, min, max, index two. That is going to take in an array, the same array, and it's going to take the same size of the array, and it's also going to take two pointers. It's going to take in p min index out and p max index out. That's going to be where we're going to pass out the minimum and the maximum value. So we can pass information back out of our functions using a pointer. I want you to try practicing that idea. On top of that, I want you to return the range of values. So if the maximum value, I think in our case, is going to be -4, and the minimum value is -4, the maximum value is 9, it's going to be 9 minus -4. So it's going to be, that's going to be the range that I have. Okay, I would like you to attempt both these exercises, pause the video, attempt these exercises on your own, and then we're going to go over the answers. Um, the actual answers in the code have been removed in case you were wondering where it all disappeared to. It's only in this video. I'm using one of our future lectures as a scratch pad to put this code in. All right, so pause the video now, and I'll see you back in a second. Okay, for the two of you that stopped it again, let's go over the code itself, and we'll see how things go. I'm going to be live coding, so we'll see if I screw up somewhere along the way. All right. So let me go into my Visual Studio. This is my preprocessor lecture. I'm going to point out that I'm making a constant integer, and very soon we'll see us defining constants versus using a constant integer. Traditionally, that the old school way of doing C code was I'd use a define, but right now we're using constant variables because it actually ends up being better for debugging. Uh, and a bit more, it's considered bad form to use the define now, but you can still use defines, and we'll see those very soon. Here I am making an array. My array has all of these elements, and notice if I'm finding the minimum index, I expect it to be at position 0, 1, 2, 3. And for the max index, I expect it to be at 0, 1, 2, or depending on how my algorithm works, 0, 1, 2, 3, 4, 5. This position right here. So 2 or 5, and the other one is 3. I also expect 9 minus -4 to be the size. So it should the range. So it should be 13 as my range. All right. So here is here I am calling min max index. I take in an array. I take in the size of the array. I return a struct, and then I'm just going to pass that struct over to the min index and the max index. I'm going to reset the values here. So here I am resetting the values, and then I'm going to call this similar function min max index 2. It's going to take the array. It's going to take the size of the array. It's going to take a pointer to min index and a pointer to max index. Those pointers are what's going to really allow us to pass information back out. All I'm saying is this is where that data is stored in memory. That's what I'm passing, the address, not the actual date. I'm passing the value, which is the address, not the actual, the number 4 or the number 17. It is an address. And as a result, since I have the address, I can then just, the function min max index 2 can actually go to that address and fill in those values or put in values in there. So I'm very consciously saying, hey, you can monkey around, you can change my data itself because I'm passing you the address to my data, not just a copy of my data. At the end of the day, I'm going to return a range, and we're going to put a breakpoint on this thing just because I'd like seeing how things work. All right, so let's go up to my functions themselves. Here is min max index. I put some stubby values in here just to see how things would work. Okay, so first things first, I need to go down my entire array, and I'm going to use a for loop because it's an array, why not? So I'm going to go down my array, and this is where I stop. This is my array itself, and what I could, perhaps the smart thing to do, let's see if I have assert included, and we'll look at includes and predefined processor things in a second, but um, I want to make sure, if I want to be paranoid, let's be paranoid. I want to make sure that no way in heck this thing is actually going to, pass in a null pointer. My code doesn't, but just to be paranoid, let's make sure it doesn't. Okay, so let's assert a nums does not equal null. Also notice, we'll talk about this in a little bit later in the lecture, I don't need to check to see if it's not equal to null. Remember, a true or false statement is either 0 or not 0. So the not 0 being true, the 0 being false. So if I have something like a nums here, if I have a null pointer, if it was null, then it's false, quote unquote. If it's not null, if I'm pointing to something, it's not false, it's true. So I can actually just write this. It's the same thing. If it was null, it would be false. If it's not null, if it's anything other than null, it's true. And so I can just put a pointer in there and just say, by the way, I am asserting that this is not null. That's what that is saying here. It's very common for C programs to do this. All right, so I've made a new min-max. I'm going to put my variables at the top. I like putting them at the very top. All right, so I have my enums. I'm making sure it's not equal to null. I'm going to make for loop, and I is equal to 0. I'm not even thinking about it. I is less than a size. I'm thinking about how to spell. That would be useful. But I'm not actually thinking about how to compose my for loop. I just made so many of these darn things. It's just second nature. It needs to be second nature for you too. All right, how do I know where the minimum and the maximum is? Well, probably want to check, I want to keep around, I can keep around the minimum and the maximum in MM. I'm going to keep the index to the minimum and the maximum in each of those positions. And so what I want to say is if mm dot min index, and I'm going to go to my anums again. So if anums at that index, I should also perhaps so mm is going to be this, mm dot min index is equal to 0, mm dot max index is equal to 0. All right, just in case. I like being paranoid. Okay, if the min index, so I have the min index here, if anums at the min index is greater than a nums at my current index, I want to change what the min index is. mm dot min index is equal to I. Fine. Next thing, I also need to check to see if it's, I'm going to just copy and paste stuff. I want to change it if the max index is also off. So if the max index is less than this value I'm looking for, then I want to change the max index. So I check to see if the min needs to be updated. I check to see if the max needs to be updated. And every single time I have one of these checks and it's true, I'm going to change my struct. I go through my entire for loop. I return mm, and oh, I already did that. So let's get rid of that. And we should be good to go. Now I'm going to do the same thing in the next function. Let's see if I can compile this. It should compile. Hey, it works. Okay, I'm going to do the same thing in the next one. Instead of doing, there's not going to be this min-max thing, so let's just copy this, or just plop it down here. I'm going to keep a range, so int range is equal to 0, just range. All right, I'm going to dump all of that code I had before in here. I'm going to, again, make sure anums is equal to something. I'm expecting, oh, I should probably also do this. Assert a size is greater than or equal to 0. Or I can make it unsigned as well. That would also be probably the smarter thing to do here, but yeah, let's do that. So no matter what, it's always going to be 0 or greater. All right. All right. So I have my for loop. I'm going through my for loop. I'm uh, going to check. I don't have this thing anymore. I'm going to need to actually keep around some value. Well, actually, I have this already, so I could just keep on reusing that. So what if I did this and then I dereference? So if that value is greater than the value here, I am going to set that, uh, change to to max here. If my max index value, well, I need, again, needs to be dereferenced. So if the value at max index out, the index there, is less than what I'm this next item I've hit, then I know I have to update that one. Okay, so this should update this max index out, max index in. All right, and now I need the range. And so the range is going to be equal to, uh, what else do I need? Oh, I should be paranoid again. I want to do this just in case you gave me some value that is out of an index. I need to be able to make sure that it is safe. So you could give the person calling this function could give me gobbledygook, could give me -1, for example, as a min index out and the min index in. If I got that, everything would just break. You're asking to go to position -1. I can't do that. So I'm going to safely set my values before I start and then do it. Now, notice the very first time through the loop, I do an extra step in the loop. I could change this to a 1 or something like that if I wanted to, because if the minimum index is equal to, uh, if the minimum index happened to be equal to 0, well, all I'm doing, I have an extra operation in here, right? I'm checking when it's set to 0, and neither of these are going to go off when it's at 0. But so I could set it to 1, and that would work just fine. I could leave it at 0. It's not going to change anything. I have one extra loop. It's not the end of the world. And since I'm just a creature of habit, I always just leave it at 0. That's just my pattern. Okay, so I need to have the min index out and min index in. I want to get this. And I'm going to put another one here. And this is going to be the max index out. So whatever my maximum index is, the value of the maximum index, minus whatever the value is at the minimum index, I'm going to take that difference, and that's going to be my range. I'm going to return the range, and that should do it for me. All right, so let's compile it one more time, and let's have a look at what we have. So I'm going to run my code and see what happens here. Okay, so here we have our array. You can look at all the nice pretty values inside of our array. Great. So I can get the min index, it's equal to 0, max index is equal to 0. If I take one step in my code, that would be, by the way, if I want to use these buttons here, this step over, my is equal to 3, and my max index is equal to 2. Wait, it's 3, 2. It's exactly what I expected it to be. Great. So that is what I would expect, and my values are correct. I'm going to reset it again just to make sure that it all works. And this thing, what I expect to see is min index is equal to 2, max, it's currently equal to 0 and 0. The min index is equal to 2, the max index is, sorry, equal to 3, the max index is equal to 2 when I'm done with it. And my range should be, we calculated 13. Okay, so let's make sure that that's going to work. So I'm going to take one, I'm going to F10 if you want to know the hotkey for this. The range is going to be equal to D. Oh, well, I don't want to see that. Let's just change from hexadecimal display to that's a range 13. There you go. Great. My functions worked as I expected to. Let's go back to the code, the We have program construction. Here we go. So we already just looked at some local variables, but I just want to review some of the things we've done already. When I call malloc, I will get just the number of bytes that I need. That's so if I need 20 integers, I multiply 20 by the size of an integer, which is 4 bytes, and that'll be how many bytes I need to allocate. Then I say, no, 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 it's not an array of bytes. It's an array of integers. I cast it. Look at casting very, very soon. I will cast it to an integer pointer, and that's my array of integers. I can do the same thing with a character array. And if I did something like, here is pointer C, if I add 3 to it, I go at position 0, plus 1, 2, 3. I'm at this position right here. I've stuffed in an X, and if I go get, and I can just put the value of X into position 3 in my array. This, by the way, these two things, the plus 3 and the using the square parentheses, are the same thing. They will do the same thing. It is, I'm going to go into box number 3 and put an X in there, or I'm going to move over 3 spaces and then look in the box. Okay. At the end of the day, when I've made dynamic arrays, I need to call free. If I don't call free, it's mine from now on, and that could be problematic. So I call free, and the next thing I always do, just out of force of habit, the compiler won't tell you to do this, but please just do it anyways, because it'll bite you eventually. Once I've called free, I set the pointer to null, just in case. If somebody tries to access pointer I, for example, it's an array. If someone tries to use this array right here afterwards, there is nothing. It's still pointing to a memory. It's still pointing to a memory address. There's nothing that says, hey, we've already given that back. As a result, you can either get weird bugs or your program can crash. And there's nothing, you can't test to see if you've already given it back. The way you test to see if it's already been given back is check to see if it's null. If it's set back to equal 0 or null, I know that I've given back the memory. That's sort of our convention. So I want to go over constants for a little bit first, and then we'll move on to it. So um, if I have a constant integer I, this will give me a bucket, and I'll put the number 23 in it initially. After I've said it's a constant, it means I cannot change it. That's the reason we're allowed to use constant variables. That's why we're allowed to use constants in static arrays, because there's nothing I can do to actually change that value. That's very much on purpose. So if I try and set I to 2, I'm going to get an error. It's a compiler error because it's a constant. We've seen this before, actually, and I want to be a little bit clearer about my constant character pointers because we've seen that, and I'm not sure if I explained it quite correctly. So here is me making a constant integer pointer. This means the integer pointer is constant. I cannot move uh, it's a changeable pointer to a constant integer. Um, so it's constant integer pointer versus this is an int pointer constant. The value it points to the constant pointer is. So let's have a look at this. I want to make sure I want to see it in code just in case I inverted them. So I have a constant, I have an integer, and it's a pointer. So it means I can change the pointer, but it's a pointer to a constant integer. This is the value it points to is the pointer itself is constant. I cannot change it around. And you can actually have constant integer pointer to constants. So it is a constant pointer to a constant integer. I cannot change the integer. I cannot change the pointer. In case you really want to lock that thing down. So if I have a number like we had in the previous slide, like I is a constant and it's 23, I need to, so this would be, I can point to something like that 23. And then the other, and vice versa. Let's have a quick look at some of these. So, but we've already seen this somewhat. Here is, I have a character, Mike Char, at size 10, it's equal to 42. I could make a constant character pointer to my chars, and I can then say, okay, well, this thing is going to now point to 56. Hey, that's fine. I can move where it points to, but it has to be to something that I cannot change. Here is, now if I go and try and change that, sorry, I'm so used to using my pen here. If I go and try and change that right here, I'm not allowed. I can't modify a particular value. I cannot change even a character, and I can't. It is pointing to a constant character. If I try and I can also can't move a couple of bits over in the dereference or anything like that. I can't set a particular value. It's all illegal. Uh, and I cannot just say my char is equal to other. So here is my char. My char. I cannot actually modify this array itself because it's a static array and I can't sort of modify it. All right. So let's have a quick look at this and try and think of these yourself. So I have a character, constant character pointer, first pointer pointing to the number 40, to the string 42. Is it legal or illegal to change first pointer to 56? And can I change the value to X? So first step, and then after that, if I have a character pointer to a constant second pointer, which is 42, can I point it to 56? And can I change the value in the second pointer to X? That's the question. They're slightly different. The constant's here, the constant is here. And I'm not going to pick on, this might be a multiple choice question, but it will not be a long answer question on an exam. So let's have a look. Oh, well, we have one, actually, we have one more. I thought we only had one. Here is a constant character pointer to 42. Okay, I'm pretty sure nothing I can do to that. I cannot change where the pointer is, and I cannot change what it's pointing to. So I can't change the array itself, and I also cannot change the actual pointer. So that one, I'm sure everything is illegal. All right. So I want to have a look at this thing. So let's change this constant character pointer, first pointer. I want to go back to my code here. I'm going to keep that, and let's pop this up. Just because I get a little paranoid with this sort of thing. So let's make a constant char pointer text is equal to hello, and then a text is equal to world. Can I change the pointer around? And can I go a text at position 2 to be equal to E, let's say. Let's see what happens. So, hey, it's already telling me I have an error. What's the error? Hopefully it should be, oh, I've got to stop the compiler. Let's stop the process from running. Okay, constant character pointer expression must not be a modifiable value. Okay, so I can change the pointer what I'm pointing to, I just cannot change the value. And in the next case, I have char pointer const a text 2 is equal to hello. And then I want to say a text 2 is equal to world, because we do not come up with overly original examples. A text 2 at position 2 is equal to E. Well, first of all, it's saying it has to be pointing to a constant character pointer. So that's going to be a problem here for this first part. That's what it's barfing on right now. I could cast it to char pointer. But this has to be a character pointer that is a constant. I cannot change what I'm pointing to. And then the next step, though, it's allowing me to change the actual value. Now, if I actually try to run this, I said, hey, I'm allowed to modify it. And then I get down here and I try and modify it. It should barf on me right on this line. It's not giving me the error because it says, hey, you can't change what you're pointing to, but you can change the values. But the actual text, I'm not allowed to change the values. So I would hope, or at least that's the hope and the dream, that this thing is going to get mad at me. Let's just comment at that line. I know that that's not going to work. I know that's not going to work. I can compile, but this is what happens if I cast something. I'm saying, I know more than you, compiler. I'm allowed to do this. And Sometimes it works for me, sometimes it doesn't. And I sort of want to see what happens here. So I'm going to remove that breakpoint. I'm going to add this breakpoint, and let's run it. And okay, so I'm pointing there. I'm going to go down one line. I'm going to change the E, and everything blows up. I get an access violation. I'm not allowed to change hard-coded text, and yet I'm trying, and I said, hey, I know more than you. It's only a character pointer. I'm allowed to change it. I go to try and change it, and it blows up in my face. This is one of the dangers of casting. We'll look at casting more in, I think, next lecture's time. But this is what happens if you try and cast and you don't do it correctly. Okay, so let's go back to our pointers one last time. And so we have the, is it legal or is it illegal? So this is a character pointer. I'm not allowed to change the original values. So I can point it to something else, but it has to be something that I'm not allowed to change the values for. So this should be legal, illegal, illegal. I'm not allowed to change the pointer itself, and that's legal. Except it's not, because I have this string. Okay, and illegal, illegal, just because you can't do squat with this thing. All right, again, null is equal to 0, which is also, so we have 0, we have 0, and we have, and we, in C++, we're going to have false. They're all the same. They all end up being the same thing, but we keep them separate so we don't sort of screw it up in our heads. If I want the character A, I put an A. I don't put the number 97, which is the ASCII value of it. I want to put the character A. It keeps it easier in my head so for me to know what I'm dealing with. I know I'm dealing with a character. If I want to have the null terminating character for a string, I'm going to use this. I'm not going to put an actual 0 in there. I want /0 as a character, just so I'm painfully aware that that's what I'm doing. It's not just some accident. I didn't accidentally put a 0 in there. I didn't accidentally put a null there. I'm consciously saying that is my null terminating character. It ends up being the same no matter what. But for other programmers, when they're reading this, they want to know what you're doing. And if I set a pointer to 0, you might be trying to set a value to 0. You don't know. If I set it to null, I'm saying I consciously am trying to make this a null pointer. So don't mix it. Despite the fact that under the hood they're the same value, try not to mix those up. If I have a pointer and I want it to set it to point to nothing, I point it to null, to 0. It's not a real location. It's something I can look at and say, oh, that thing is null. I know I can't do anything with it. Um, when I'm done with a pointer, I always set it to null. When I make a pointer and I haven't initialized it to something, to point it to something, I point it to null. It is a safe value to point things to. Uh, if we don't, if we fail to allocate enough memory, so I make some ridiculously big array with malloc. So it had, I don't know what ridiculously big nowadays is, but let's say a gigabyte of memory with malloc. It will return a null pointer, or if it doesn't have the memory available to it, it'll return a null pointer. Therefore, you need to actually check to see if something is a null pointer at all times. It can be with an assert, it can be with this. If it's equal to null, spit out something, whatever the case is, whatever works for you. Or not whatever works for you, you need to check. There are multiple different ways of doing it. So, because you don't know if malloc is actually going to return something. 99.999% of the time it returns something, but I have had cases when it returned null because it didn't have enough space or I couldn't get enough memory. Uh, and this, by the way, this is equivalent of C pointer C1 is not equal to 0. If I just put in the pointer itself, because it's either 0 or not 0, false or true. Uh, and then we can just return the address. Okay, so what's wrong with this statement? So here's an int pointer. It's going to be equal to 0. Am I allowed to do that? Well, technically I can't. Why? For a second, I thought I didn't see the star there or the asterisk there. Pointer's not pointing to anything. it hasn't been set to anything, pointing to anything. So therefore, I cannot set what it's pointing to. There's no, essentially, there's no bucket it's pointing to. There's no place in memory it's pointing to. So how am I supposed to dereference that? Number two, if I have a character pointer and then I set the character pointer to equal X, what's wrong with that? Well, X is a character, it's not a string. This thing is a pointer to a character string. What I would need to do is, put it at position 0 or dereference it. And here, so I'm going to go over the answers on each one of these things. So this is, I am pointing to some bucket of characters, and you're saying that entire bucket of characters is X, and no, 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 I need something like this. This thing is PTR is pointed to question mark, question mark. And, oh, actually, this is also not pointing to anything. And let's have it point to some kind of malloc thing. And y, and y is going to be, or let's make it a char or something like that. There you go. And let's just erase this thing here. I'm pointing to something, but can I actually just go into it? No, it's not actually, it's not, what originally wasn't pointing to anything. Now it's pointing to something, fine. But pointer 2, despite pointing to something, I need to dereference it. It's actually it's a pointer. I can't just change things. So this needs to be pointing to something. That's what the problem is. If I am pointing to something, it's still a pointer. And in this case, I'm calling malloc. What the heck's wrong with this thing? Well, did I want an array of 18 characters? Well, 18 integers? Because I sure as heck am not getting that. In fact, that's why I use 18 instead of 20, because it will not get me a proper array. This will give me an array of four 4 ints plus 2 bytes. I would need some multiple of 4. An integer is 4 bytes long. This is 18 bytes of information coming my way, and an integer takes up 4 each. So I cannot, it's not some multiple of 4. What I really need is the size of in here. And sorry about the horrible handwriting on my computer. And recall that size of does not tell you the size of my array or anything like that. It is the size of my basic variable type. So the size of an integer, the size of a character, not the length of a string. That's a different beast. Size of is how big that type of basic memory is. So here I have made some kind of malloc. I can try and I'm going to output some value. And oh, we have another problem here. The pointer is pointing to this chunk of memory. And what's this going to print off? This is actually going to print off whatever the address of that pointer in memory is. It's going to be something weird. It's not going to be some value. It's going to be some address. All right. So where are our common pitfalls? Where does, I like pointing out where the landmines are. So number one, we use a pointer, we don't, before we initialize it. The first thing I do, as paranoid me, the first thing I do when I get a pointer, I better point it at something or I make it null. That is my sort of my standard operating procedure. Because if I don't do that, I invariably forget, and like 20 lines down, I start using that pointer. It is ridiculously common to do this. So set your pointer right away, just to be on the safe side. Even if it's set to null, you can at least check for null, or you'll get a null pointer exception. But normally you want to set it to something right away, and then I can modify it. If I'm using allocated memory before initialization, so I call malloc, and then I start getting stuff in my array. Well, it's going to be garbage in there. Malloc doesn't set things. Calloc will set it all to 0. Malloc will give you whatever was there before, at least when you finally do a release build. So right now we're doing these debug builds. They set things to safe values. If I go and do a release build, something like I'm making a video game, Malloc will give me whatever was in memory beforehand. And I have no idea what that's going to be. I want to make sure I set my values before I use them. And then the big one of the big ones, and the one that gets you later on, is memory leaks. If I don't release my memory when I'm done with it, but I don't call it free, it's still mine